พี่
So I'm writing some equation. Please take a look.
That's flexi. My friend, my lecturer.
P is calculated by rho P H indicates the elevation. G indicates the acceleration due to gravity, and rho indicates the density. Another equation is specific gravity. Specific gravity is Sg, which is defined by rho density of liquid to the density of water. Rho indicates density, unit is kilogram per meter cube, and rho W indicates density of water. Okay? Remember this. So what we can write? So pressure we can express again by specific gravity times density of water times G and H. Okay, this is another equation. So in this tutorial, I am using this equation. Take a look. P pressure is given by specific gravity times, this is 1000, G is 9.8, H. So unit is Pascal, or P becomes 9800 specific gravity times H. This unit is Pascal, or you can use pressure 9.8 times, you can put it here, specific gravity times H. This unit is kilopascal. Alright, I am using this equation. Pressure becomes 9800 times specific gravity times H. So specific gravity of water is 1. Alright? Specific gravity of water is 1. Specific gravity of mercury 13.6. And oil maybe 0.8, 0.7, 0.9, whatever. So if I use 9.8, unit is kilopascal. This is a difference only. H indicates the elevation, height. Unit is meter. So I am writing the unit of H. Okay, Sg for water. Specific gravity for water 1, right? And specific gravity for mercury is 13.6. And these values are given to you in the question, and H, unit of H is meter. Okay? What is pressure? 9800 times specific gravity times H. Done. So I am going to the next slide, which indicates question number 1. Okay, you can submit assignment after class, no problem. So those who come here, please write down the equations, or you can take picture of these equations. Because I am using directly pressure 9800 times specific gravity times.
Bring a whiteboard.
Okay, I am using this equation directly. I am not writing P1, P2, no need. Or if you write 9.8, unit is kilopascal. If you write 9800, unit is Pascal. Remember, in that case, specific gravity must be given. Alright? So now I am going to question 1. Okay. Question 1 tells you 2 layers of fluid are dragged along by the motion of an upper plate. Okay? The question is 2 layers of fluid. 2 layer means this is layer 1. I can say this is layer 1. This is second layer, right? Layer 2. 2 layers of fluid are dragged by upper plate. So this indicates the upper plate. Okay, I am writing here. This indicates upper plate. Right, upper plate. Two layers of fluids are dragged along by the motion of an upper plate, as shown in this figure, with the bottom plate remains stationary. That means upper plate is moving, right? Upper plate is moving. I can write this plate is moving, right? Moving, and there is another plate. I put it here, the green color. This is the bottom plate, and this bottom plate is stationary condition. Bottom plate is stationary, it is not moving, right? Stationary. That means it is not moving. So this means that the velocity of this plate is 0, right? Doesn't move, stationary, fixed. The velocity of this plate is 0. And the velocity of this plate, some number, right? Which is u. The tail here, it moves 3 meters per second. Okay? So this is the velocity of upper plate. Okay, so they tell you determine the ratio of shear stress on upper plate and that of lower plate. They tell you to find the ratio of shear stress. Ratio of shear stress between upper plate and bottom plate. Shear stress at plate 1, shear stress at plate 2. They tell you like this. Tau indicates shear stress. Shear stress at plate 1. Shear stress on plate 1. 2. Shear stress on plate 2. Shear stress on plate number 2. You have to find this question. You have to find the ratio. Okay. By definition, shear stress is given by, take a look, tau is defined by mu delta u by delta y. U indicates the velocity and y indicates the distance. Okay? So this one I write d. J is confusing what? I better write d. It's all d. So u indicates the velocity. U indicates the velocity in meter per second, and y indicates the distance. This indicates y, this way, and this indicates the velocity. So if I draw, then you can see, okay, if I draw like this, so this direction indicates y direction. So bottom of the plate is here. Bottom of the plate is here, right? This indicates the bottom of the plate. The value of y here is 0, correct? Bottom of the plate, the value of y is 0. So what here is the layer of the fluid. So one layer is present here, and another layer is here. So at that point, the value of y is 0.04, right? And at that point, value of y is 0.02. 0.04 at the point. So what is the velocity here? The velocity here is 0. At the top point, what is the velocity? Okay, if I say velocity start from here, for example, this is the starting point. So this is 0, right? So velocity maximum is from here to here. We said this is the maximum, right? So this from here to here is 3 meter per second. And from here to here, according to the question, is 2 meter per second. Is the velocity adjacent between the two layers, here and here. So this velocity is 2 meter per second because the layer is also moving. That's why. So this is moving, the layer is also moving. Okay? So this velocity is 3 meter per second and the layer velocity here adjacent to the layer is 2 meter per second. The bottom of the plate is 0. Correct? So what is the velocity here? So this is the highest, right? And this velocity is lower than this value, right? So this one is lower than this value. Something like this. And finally it comes here 2 meter per second. But here is 0. At that point, slightly higher. At that point, slightly higher. At that point, slightly higher, right? At that point, higher. So I can draw the velocity profile. So can I draw like this? I just join these two lines. Correct. So at the point, the velocity is this one. At the point, the velocity is this value. At the bottom of the plate, you can see the velocity profile is like this. It's different, right? Here is this profile, here is this profile, and y equals to 0. At that point, u is 0. Okay? So here is layer 1, we assume this is layer number 2. So what is the shear stress equation? Mu is the viscosity. So at the point the viscosity is given 0.4 Newton second per meter square. Layer 2, the viscosity is 0.2 Newton second per meter square is given. It's very simple. Tau 1 is mu 1 du by dt in layer 1, right? And layer 2, tau 2, mu 2 times delta u by delta y at layer number 2. I can write this. So, okay, you can see at layer 1, I am to look at that point. I am looking at that point. So, tau 1 becomes mu 1 times du by dy at layer number 1. Correct, I can write it, no problem. Then, what is mu 1? I can substitute the number. So, mu 1 becomes 0.4, right? 0.4. Done. What is du? Can you tell me what is du? Difference between, because they do not give me any equation. I do not know, right? It looks like a linear equation. So I can write du becomes 3 minus 2, right? Correct. In this layer, upper velocity is 3 meter per second and lowest velocity is 2 meter per second. Right? I can write 3 minus 2 is du. What is dy? 0.04 from here, 0.04. And here is 0.02. This is dy. I can write. Then you can see, I can write du becomes 3 at layer 1, right? 3 minus 2 divided by 0.04 minus 0.02. I can write it, no problem. Then I can find 20 Newton per meter square. Right? Now I am looking at layer number 2. At layer number 2, I can get tau 2, right? mu2 times du by dy at layer 2, right? At layer 2. Then I can write what is the value of mu2. Mu2 is given here 0.2. What is du? Tell me. Du is, what is the maximum at layer 2? 2, right? What is the minimum? 0, 2 minus 0. Right? What is dy at layer 2? Here is 0.02. Here is 0. Then I can write, this becomes 2 minus 0 and bottom is 0.02 minus 0. Then I can get tau 2 becomes 20 Newton per meter square. So what is the ratio? 1, right? Tau 1 by tau 2, 20 by 20. 1. This is the answer. So you understand? Not difficult, right? But problem is, this question is simple. The problem is if I give you the equation, right? If I give you y, can you solve this question if y is like this? Can I go to next slide? Can? Okay. I don't have any space. Okay. Can I do like this? If I say, if u is like this, u is a function of y, then you have to do integration. For example, I can write here. So, I can write y, u is a function of y. That means u becomes u naught, okay? u1 y, u2 y squared, u3 y cubed. So what do you do? Complicated, right? In that case, these are all coefficients. u0, u1, u2, u3. All values should be given. Should be given to me. Otherwise, you cannot solve it. Then you have to write this way: du by dy. Then you can write u0 d u0 u1 y u2 y squared u3 y power 3, right? By dy. Understand? Then you can write u1 plus 2 u2y plus 3 u3 y square, right? You can get it. Then value of y you can put. This is the gradient of it. Right? They give you true law. This is y equals to 0. Then they give you y equals to 3. For example, some number law. Right? Then you put the equation, then you can get the gradient. Okay? These may be complicated cases. Not easy, okay? This question is easy. Because this is a linear equation. But if I give you something like this, the profile, u is not like this. If u is something like this, right? If u is something like this, then how you can solve it? Something like this, right? For example, how to solve it? Okay? And this equation not like this is different. Okay. Okay, this question. Question number 2. An inverted 0.1 meter diameter cylinder is partially filled with water. Okay? Its diameter is, D is 0.1 meter. is partially filled with water and covered by a plate. This is covered by a plate. This is a plate as shown in this figure. A force 20 Newton is applied to pull the plate away from the cylinder. Okay? So this amount of force is applied, Fp 20 Newton, to pull away from the cylinder, right? Determine the air pressure inside the cylinder. Neglect the mass of the plate. So what do you understand from here? So what is the, here is air pressure, right? So air pressure is acted on the surface of the water, right? At the same pressure. But water pressure vary how? At that point, what is the water pressure? At that point, what is the pressure? Air pressure, right? At that point, rho g, the distance from here to here, correct? At that point, the distance from here to here. At that point, the distance from here to here, right? When it comes here, rho g h. Alright? So what is the magnitude? Rho g h, air pressure. So this pressure plus this pressure, right? Times the area. Then I can get the total force acted by the water and air together. Right? So what I can write here? I can say, here is the air pressure. Right? And water pressure is acted rho g h. How it varies? This way, right? At that point, the water pressure is the lowest. At that point, water pressure is the highest. Can I draw like this? Magnitude wise. That is acted downward. Not this side of the wall. No. Water pressure at that point, same. Horizontally same, but vertically they vary. What is the magnitude? At that point, magnitude is 0, right? At that point, the magnitude increases. At that point, magnitude increases. At that point, magnitude increases, right? Here is the highest value for water pressure, right? But air pressure is vary, all are same number. Okay? So here I can get air pressure, PA, and here I get water pressure. So can I write like this? Here I get water pressure, and here I get, here I get air pressure A, here I get water pressure. Understand? So what I can write? Air pressure plus water pressure times area of the piston is equivalent to force that is acted here. Correct. Then I can say this is the total pressure, right? Total force, Ft. So I can write, force balance tells me Ft plus Fp, cool. This one I say Ft is equivalent to 0. Agree? Because the mass of the cylinder, this one provides some mass, mg is neglected according to the question. If mg is given, so Ft plus mg plus Fp is equivalent to 0. Agree? If this is given, mg plus this, just force balance. Any question? In this question, they tell you the mass of the piston is neglected. But in the exam, they tell you the mass of the piston should be considered, right? So what is Ft? So this is equivalent to total force that acts on the water and air. And Fp is equivalent to 20 Newton. So what I can write? Can I write this way? From here I can write Ft becomes minus Fp. Then from there I can write Fp becomes area of pressure of air, pressure of water times area of piston. This is minus 20, this is Newton, right? Alright. They tell me please find the pressure of water. So pressure of air, what is water? Rho G H. What is the value of H? 0.2, right? Is equivalent to minus 20. What is the area of piston? Pi by 4, right? Times diameter 0.1 square. Then I can write PA plus, what is the rho G? Remember 9800, remember, right? Rho G becomes 9800. I have written in my first slide. 9800 times specific gravity, which is 1 for water. So I can write 9800 times specific gravity 1 times 0.2, right, is equivalent to, I did some calculation before, so this becomes minus, this one we get 2546.48. Then after that you can get PA becomes minus 4506.48. Alright, this is Pascal. Because this is Newton. So what is the air pressure? PA becomes minus 4.51 approximately kilopascal. So what do you learn from this question? Air pressure vary. In every point air pressure is same. If water level is here, same here. Here, same here, right? Same. So why negative? What do you mean by negative pressure? Negative means suction pressure under sub-atmospheric condition. Any question? No. Alright? Okay, this one. In this question, they tell you determine the elevation difference H. They tell you, please find the elevation difference delta H. Okay? Between the water levels in the two open tanks in figure 3. Right? So this indicates one tank. Take a look. This indicates one tank. One tank. This is another tank, right? So this indicates water level and this indicates another water level. The difference between the two water level is delta H. And you have to find the value of delta H. How? How you can solve this? I show you here two methods. Okay? Okay. At that point, what is the pressure? Atmospheric pressure, right? Yeah. Definitely. At that point, rho G H. Very good. Rho G H. From here to here is rho G H. Right? And from here to here, minus rho G H, right? Correct. So rho G H minus rho G H is 0. I come back here. So first I go here, then come back here. Same thing, right? No problem. Agree? Okay. If I start from here to here, rho G H. From here to here, I put here the value from here to here is x, right? Second right. From here to here is x, then that means rho G minus x, right? Upward is negative, downward is positive. From here, rho G times 1 minus x. From here to here, same fluid, rho g times h. Very good. From this distance and this distance are same, right?
Yeah.
And we can cancel each other. No need. Because this is negative, this is positive. Same fluid, neglect. But different fluid, no, you have to consider. From here to here is 0.4.
Yeah.
That means plus.
Low G.
No specific gravity is there, different fluid. Specific gravity is 0.9.
2.9.
There is water 1. So rho g h times specific gravity 0.9. And from here to here, h minus 0.4. From here to here, delta h. Right?
Yeah.
Now you can see how I solve this. I'll show you two methods. This, what is the value here? This one is equivalent to, I write, the red one, right? So red one is equivalent to, tell me. Red one is equivalent to rho g h means gamma, right? I can also write rho g becomes gamma. No problem. Right. Then I can write this one becomes specific gravity times gamma of water. Same thing, no problem. Okay.
No problem.
So what I write from here to here, the red, what is the value of red one? Gamma of water, right? Gamma of water means times 1, right? Specific gravity 1. Times 1. Then what is this value? What is this value? The blue one is equivalent to negative, right? Negative gamma of water times x. Correct. Specific gravity is 1. Then what is this value? Minus, right? Minus gamma of w times 1 minus x. Correct. Then this value minus gamma of w times h. Then what is this? Positive, right? This one becomes positive. Specific gravity is 0.9, right? 0.9 times gamma of w times 0.4. Then this value, what is the distance from here to here? This distance is equivalent to h minus 0.4, correct?
Yes.
Then from here the distance becomes plus, right? Going downward. Fluid is water, here is water.
Yeah.
So I can write gamma w times h minus 0.4. Right, and finally this value. The last one is equivalent to positive, right? Water times specific gravity 1 delta h is equivalent to 0. Then you can get it.
Wow.
Understand? Very simple. From here to here, positive. From here to here, negative. From here to here, negative. Here to here, negative, right? Here is all water. I put gamma w. Or you can write rho w g, same value. Then from here to here, positive. But here I write specific gravity. Right? Why? Because another fluid. Then moving down again. Same. Gamma, here is again water. Times h minus 0.4. Because the distance from here to here is h, we assume here is 0.4, here is h minus 0.4. And here the distance is delta h is given. You have to find this number. Right? And after that is equivalent to 0. Alright? That's all. Then
I can skip.
can
I
hear
show you here.
minus
This is the answer.
Okay.
Okay.
Okay,
Here
Eon.
I write here
minus
0. This
Take
one
with
is
the first
equivalent
three.
to. If you consider air pressure plus this one plus this one plus this one plus this one is equivalent to again air pressure. Same thing. Right? In this method I show you, I consider the air pressure. If you consider the air pressure, obviously it comes here and air pressure law. It comes air pressure. Or you can cancel them. If you consider absolute value, you can consider absolute value. This one and this one is cancelled. Alright?
Alright.
Same. Just traveling. You start your journey from here. That's all.
Okay, skip.
Okay? And you
Take is
do
equal to
the
zero.
summation of pressure.
Okay, skip.
Summation of pressure is
Same
equivalent to
liquid.
0. Alright? Summation of pressure is equivalent to 0. Then I can get it. After that,
No, if it's the
just
same.
understanding, nothing new. Then, after that, what I do? I just do,
Cancel.
just cancel each other. Because some are double counting, just cancel. And finally, I get, I substitute the value, and I can get delta H is 0.04. This is the answer. Alright? So this is one method. And another method I can show you later. And this method is easy to understand. Just summation of pressure is equivalent to 0. Just close your eyes. Right? So delta H is 0.04 meter. I get it the answer. You can keep it. And at home, just practice. Okay, if I write everything, I cannot finish in time. Okay? So that's why I just show you. So any question? No question. Okay. Another method. In that method, I can calculate this pressure, right? What is this pressure? Can you tell me? What is this pressure? I can calculate from here, right? H, Y cancel, right? I can write this. Tell me, what is this value? P1 and P2 are same, right?
Yes.
P1 and P2 are same. Why?
Atmosphere. Whoa.
Alright? So what is the value of P1? Tell me. P1 is equivalent to? No? P1 is equivalent to? Rho G, this H. This H. That means here is water, right? This is water. That means I can write gamma of water times H. What is the value of P2? Tell me. Here is P2. The value of P2 becomes, tell me.
Low GH plus
Specific gravity, right? Times rho times G times H. What is the value of H?
H plus
3.4 plus rho G of water times H minus 0.4, correct? Plus rho G delta H. So what I can write? So P2 becomes, I can start here, right? P2 becomes, what is the value of specific gravity? 0.9, right? 0.9 times gamma of water times 0.4 plus gamma of water times H minus 0.4, right?
Yeah.
Plus gamma of water times H. Then I can write P1 and P2 are same. If you follow this method, then you can write this value is equivalent to this value. Problem is solved. Okay? So now I show you the method.
Same thing, I just make a zero different.
P1 I can show you. Because in that case I add also this. Because they cancel each other.
It's exposed to outside.
Oh,
Both cases you have to add. If you do not add, never mind, it's fine. P2, I add this number.
It's the same fluid.
Alright? Same.
Yeah.
So this one and this one, they cancel each other, right? Then after that I can write P1 and P2 are same. Why I consider here? To explain you. If you consider from here to here, never mind, it's fine. If you consider from here to here, it's fine. But this value and that value cancel. Then I can write P1 and P2 are same.
Same method.
Then finally I can get exactly the same number. 0.04. This is the answer. Alright? What is the method? Method is summation of pressure is equivalent to 0. One method. And another method, you choose. Choosing is very important. How to choose? You have to choose some point. But you cannot choose anyhow. Okay, in that question, how you choose? In that question, at that point the pressure is T1. And they tell you, you have to find the specific weight of the unknown fluid. Specific gravity, right? Or density. They say density of the fluid, unknown fluid.
Okay.
So what is the concept? So at that point, pressure is this point, right?
Yeah.
So this pressure and this pressure, same or different?
Same.
Why?
Fluid.
Because?
Same liquid.
Because of
Same height.
same height.
Same head and same liquid.
Yes.
Yeah.
Two together, not one.
Whoa.
If air is different fluid,
Different.
no.
No.
For example, this fluid is specific weight is 25 kilonewton per meter cube. If this position is here,
Different.
for example, in that case you cannot say this pressure and this pressure are same. Never. Impossible.
Okay.
Should be same fluid and same.
Understand.
Two together, not one. This is the concept. Okay? So now, this point and that point, same pressure. Then I can play the game, right? So which point I can choose? This is the question. This is the easiest way that I show you here. X and Y you can choose here. Why? Take a look. In that question there are how many fluids?
2, 3.
Three fluids. This is number 1, this is number 2, and this one unknown fluid, number 3. 3 types of fluid. So when you calculate, all effects must be there. All 3 fluids effect must be there. Otherwise, if you choose, okay, I choose this point and that point.
Different.
Friend.
Cannot.
Cannot.
Not good.
Why not?
Can. Not the same pressure.
Can.
Difficult.
Yes. This fluid and this fluid. If you choose this and this, same fluid, right? If I choose this point and here, you cannot solve it. Because you miss this fluid. So that's why you have to choose point, judicially. Not anyhow. So if you cannot choose, then you follow the traveling method.
Why cannot choose the P1 there?
This point and this point, you choose. Yeah. And how to solve it? Because you do not know others. Okay? Or you can choose traveling method. I start my journey from here and ends here. Done. The summation of pressure is equivalent to 0. Okay? Then you can see, right?
Okay.
Then I start my journey from here and ends here. And what I do? First one I write 3 times. I start from here. From here to here. Is this value? -3 gamma water specific gravity. This is the height. This value. And after that I choose this value. -3 because it's moving upward. -3 times gamma times 1.1. Right? So in the horizontal direction, at every point, the pressure is set. We do not need to consider. Now I consider from here to here. 9 times positive. Then you can see, later I do positive 9 times. The distance from here to here. And this value. Plus. Right? Then I do here, from here to here is 4. This value is 4, right? Up to here, 4. Then I write 4 times gamma. We assume the specific gravity or specific weight of this fluid is gamma, which is 25. I just put here. And here is 1. Then I put here 1. Okay? And then negative. This one. Then negative is unknown fluid, right? This is 4. 4, then 3. 4, then 3 is equivalent to 0. Done. Understand?
Yes.
This is the easiest tool.
Easy.
Now I substitute the number. After that I substitute all the number and finally I get 3 times gamma H2O specific gravity, 4 times gamma, 7 mu y. This is the unknown fluid. This is the density of unknown fluid. Alright? Then unknown fluid density is this. So gamma, this one I put 9800, right? So this one 25 times 10 power 3 because I have to convert kilonewton to newton. Because I am going for 9800. This is the result. And in that case, the density becomes kilogram per meter cube. Alright? So in that case, you have to calculate, carefully. Okay? So what is the mu? I know. Rho times G. G indicates 9.8. Alright? And density of water I put here 1000. So density of the fluid is more than 1000. 1930. Alright? Any question? No. This is the easiest method, right? So another method I show you. This is another method. In another method, I choose this pressure. At that point, pressure is P1. And at that point, pressure is definitely P1. Okay? Now I give you one question. Can you tell me what is the value of P1? What is the value of P1? This one, right? P1. Correct? Here also same number, P1. Same thing. In the traveling method, I add P1 and I remove P1. Cancel. And finally, I get the same value. This one, equivalent of this one. Right? Then I can say the pressure from here to here I choose this point, right? The pressure from here to here is equivalent to the pressure from here to here. That's same. Then I can say this is Py, right? I say this is Py. Py becomes P1, this is Y, P1 plus, this is unknown fluid, gamma U times 7. Then Px becomes P1 plus, this is the water, right? Gamma H2O times 1.1 is specific gravity up to here. Then this is the unknown fluid. Unknown fluid is 25 times 10 to the minus 3 and height is 4, right? From here to here is 4 unknown fluid. 4 and here is the 3. There is 3, there is 4. Alright. Then I can write Px and Py are same. Py is equivalent to Px. Then I substitute the number and finally I get this equation. Same answer I can say. Understand? In the traveling method, I add P1 and minus P1. Same thing. And this method is useful. Why? It saves you time. Okay? If you have enough time, then you can do traveling. If you do not have enough time, then you do this method. Alright? And what is the concept? Same fluid, same height, same pressure. Alright? And when you choose the point, you consider the effects of all fluid. Okay? This is the concept. So now you can choose the point. Any question? No. Any more question?
Okay,
No.
go.
No. Question 5. This one also same thing. This one I show you the easiest method and traveling method you do by yourself. Okay. Okay. At that point the pressure is PA. Am I right?
Yeah.
At that point what is the pressure?
Minus.
PA. Why you are worrying? At that point what is the pressure?
Where?
PB. At that point?
PV.
Yes. Because of the same fluid and same height.
Good.
Done. And we choose the line at that point. Because all effects are present. Correct? So what is the value of pressure P1? Is given, right?
Water.
No. Pressure P1 is given here. Minus 30 millimeter Hg. You have to understand the meaning of this.
Okay.
What is this? What is the meaning of this? I am writing here, not writing here. PA minus 30 millimeter Hg. What is the pressure? Equation? Rho G H, right? Specific gravity, rho of water, G H. You remember, right? What is this value? Specific gravity of mercury, 13.6. This one, 9800. This one, negative value, right? Minus 30 millimeter, right? Should be multiplied. This is the meaning of this. PA. So what I can write? PA becomes, I'm writing here again, PA becomes minus specific gravity of mercury 13.6 times 9800 times 30 by 1000 Pascal, right? All right. So this one you can calculate. Then this is water, right? So what is the value of Px? Tell me. Px becomes Pa plus gamma of water, right? Gamma of water times 0.15 plus mercury, right? 13.6 times gamma of water times 0.3. Correct? Because this fluid is mercury, this fluid is water. Similarly, Pb, what is the value of Py? Tell me. Py becomes Pb plus specific gravity of oil 0.7 times gamma of water, right? And what is the height from here to here? 0.45 times 0.45. Then I can write
Px equal Py.
Px and Py are same. Then I can write Pb plus 0.7 times gamma of W 0.45 is equivalent to Pa, right? Pa, this value you can plug in here. Pa gamma of W times 0.15 plus 13.6 gamma of W 0.3. Right? And I get my answer Pb here 34.3 kilopascal. I hope that you can solve it, right? No problem. I do not see here any problem.
What?
Pa is this number. You can calculate from here and put it here. Any question? In that question, the value of
Just
gamma
thought you are.
W is 9800. Not difficult.
Oh, mercury. Oh.
So you have to solve by yourself. Practice. So I give you the assignment, good or bad, you practice at least, right? If you copy, not nice. But you should practice. If you do by yourself, I'm sure in the exam you can solve any question. No problem. At least you are not afraid of question, right? If you do not solve anything in the exam hall, you will be scared.